Dear students, along with the NAD and the FAD, one more type of the electron carrier which is present in the or which plays a very active role in the electron transport system, which is nothing but the ubiquinone. Ubiquinone, it is also called as the, or it is abbreviated as the Q, or sometimes it is also called as the coenzyme Q. So here this ubiquinone, which is a small molecule, which is nothing but the lipid soluble benzoquinone with a long isoprenoid side chain. So this is the benzoquinone ring, and in turn it is associated with the isoprenoid chain. Since it is a very small molecule, it is also hydrophobic. It is freely diffusible across the inner mitochondrial membrane, and in addition to that one, it is also going to act as a mobile electron carrier. This, since it is an electron carrier, so here how many electrons it can carry and how many electrons it can donate. So here what is the capacity of acceptance and the donating the electrons of this ubiquinone. So here this ubiquinone, which is also abbreviated as the Q or the coenzyme Q, as I already told you, it is a benzoquinone ring. In turn it is associated with the long isoprenoid chain. So here this ubiquinone, it can accept maximally 2 electrons under the two protons and completely reduce into the ubiquinol. Okay, so here this ubiquinone, if it is accept only one proton and the one electron, it will be halfly reduces into the semiquinone radical, which is also written as the QH dot here. And here if it is accepted the second proton and the second electron, it is completely reduced into the ubiquinol, which is abbreviated as the QH2. It will be completely reduced, or it will be fully reduces. So here, since as I told you earlier, this ubiquinone, it is a small hydrophobic molecule, acts as a mobile electron carrier, which is going to transfer the electrons from the one complex to the other complex in the electron transport system. And here, and this ubiquinone, it will be having the some of the closely related compounds which are present in the other system, which is nothing but the plastoquinone, so which is present in the plant's chloroplast, whereas the menaquinone, which is present in the bacteria. So here this plastoquinone of the chloroplast and the menaquinone of the bacteria, they play an analogous role to the of the ubiquinone. So here the ubiquinone, since it is going to act as an electron carrier or mobile electron carrier, similarly these plastoquinone and also the menaquinone, they also act as an mobile electron carrier in their respective system. The plastoquinone in the chloroplast, whereas the menaquinone in the bacteria. So here, in addition to the NAD and the FAD, the ubiquinone also, it is an electron carrier which plays a very important role in the electron transport system. Okay, so coming on to the other type of the electron carriers, which plays a very important role in the electron transport system, which is nothing but the cytochromes. So here these cytochromes are just nothing but the proteins which are having the heme as the prosthetic groups. So here what are these cytochromes? These cytochromes are the small proteins which are having the heme as the prosthetic groups, similar to that of the hemoglobin and the myoglobin, where those proteins also having the heme prosthetic groups. And similarly these cytochromes are the proteins which are present in the mitochondria. They will be having the heme as the prosthetic groups. And here the mitochondria will be having the three classes of cytochromes, and they are designated as the A, B and the C. And here these three classes are designated based on the type of the heme prosthetic groups which is present in them, and along with that one the absorption maximum which is going to be seen by those heme prosthetic groups. Whereas the A type cytochrome, A-type cytochrome, which can accept maximally at the 600 nanometer, whereas the B-type cytochrome, which can accept maximally at the 560 nanometer, whereas the C-type cytochrome, which can maximally accept at the 550 nanometer. Okay, and here these three structures are nothing but the heme prosthetic groups which are present in those three types of the cytochromes. Okay, and here this is the heme prosthetic group, which is nothing but the iron protoporphyrin 9, which is present in the B type cytochrome. And here this heme prosthetic group, which is tightly associated with the protein part, whereas this is the heme which is present in the A type cytochrome. And here this A type cytochrome, so here also it is tightly associated with the protein part. And here this heme A, which is also, it will be having the long isoprenoid chain. Whereas this is the heme C, which is present in the C-type cytochrome, and here this heme C, it is covalently attached to the protein pod. So here with the help of the cysteine residues, whereas the heme A and the B, so here they are just tightly associated with their protein pod, whereas the heme C, it is covalently attached to their protein pod. That is the difference. Okay, so here in similarly, so here the cytochromes are just nothing but the proteins which are having the heme as the prosthetic groups, and here based on their absorption maxima, we are going to having the three classes of the cytochromes, the cytochrome A, cytochrome B, and the cytochrome C. Okay, and here these cytochromes are just nothing but the single electron carrier, because these heme groups at the center, they will be having the iron atoms. So here this iron atoms, it will be reduced and oxidizes from the ferric form to the ferrous form, and the ferrous form to the ferric form, and here so here by doing so, so here all these three cytochromes are just nothing but the single electron carrier. So here all these three cytochrome, they can accept only one electron and they can donate only one electron. They are just nothing but the single electron carriers that we need to remember. Okay. So here it is regarding the cytochromes. And coming on to the last type of the electron carriers, it is nothing but the iron sulfur centers. So here the some of the proteins, they will be having the iron sulfur center as the prosthetic groups, and those proteins are called as the iron sulfur proteins. Okay, and here in these proteins, these iron sulfur centers, so here the iron atom, it is associated with the inorganic sulfur atoms, or it will be associated with the sulfur atoms of the cysteine residues of the protein part. Okay, so here the iron sulfur proteins, they will be having the iron sulfur centers as the prosthetic groups, where the iron atom, it is associated with the inorganic sulfur atom, or it will be associated with the sulfur atoms of the cysteine residues of the protein part. Okay, so here these iron sulfur centers or the iron sulfur proteins are also single electron carriers. Okay, so here in this case we can look at the three different type of the iron sulfur center, and it is the first type, it is called as the single iron sulfur center, where the single iron atom, it is associated with the, or it is coordinated with the sulfur atoms of the four cysteine residues of the protein part. It is nothing but the single iron sulfur center, and it is nothing but the 2Fe 2S center, where the two iron atoms are associated with the inorganic sulfur atoms, at the same time the sulfur atoms of the cysteine residues of the the protein part of the iron sulfur protein. It is called as the 2Fe 2S center, where it will be having the two iron atoms, and it is nothing but the 4Fe 4S center, where the four iron atoms are present. All these four iron atoms are coordinated with the four inorganic sulfur atoms. So here these are the inorganic sulfur atoms, and in addition to that one, they are also coordinated with the sulfur atoms of the cysteine residues also. Okay, so here these are the different types of the iron sulfur proteins. So here these iron sulfur proteins are just nothing but the proteins which are having the iron sulfur centers as the prosthetic groups. So here these iron sulfur proteins are also electron carriers. So here how many electrons they can carry? So here irrespective of the number of iron atoms which are present in them, so here all these different electron carriers, they can accept only one electron at a time, and they can donate only one electron at a time. So here they in general, in other words, nothing but they are just nothing but the single electron carriers. So here in all these cases, one of the iron atom will be reduces and oxidizes, and they are going to just donate or they are going to just mediate the only one electron at a time. So here in simple words, I can just tell that all these iron sulfur centers are just nothing but the single electron carriers. Okay, so here up to this we discussed about the different types of the electron carriers. Okay, so here thank you.